Welcome, everyone. My name is Chuck McAuliffe, and I'll be your host today. Today's webinar is entitled Work Process and Organizational Changes for Successful Asset Management. I want to again thank ISA and the FTT Group for coordinating this exciting event. As you see in the title of the next slide, there's a drive today to increase plant reliability. And what is plant reliability? Well, reliability has to do with the elimination of failure modes and the management of resources to minimize the frequency of unplanned failures. Each plant may have their own definition of reliability, but let's look at the result of the Instrument Reliability Program established at the Dow Chemical Deer Park facility in Houston, Texas. 85% reduction in reactor trips, delivering millions of dollars in earnings before interest and taxes. There's probably very few things that you can do at your facility that can get that kind of return on investment. And look at these bullet points here regarding instrument reliability. Reliability can deliver value to the bottom line. It's scalable, so regardless of the size of your facility, you may be thinking, Dow Chemical, a lot of resources, big company. No, what we're going to be talking about today is a scalable program. Start small, go big, start big, whatever you'd like. So it really does apply to everyone on the call today. And maybe it has a low cost to implement because you may have intelligent devices that are already installed at your plant. But the key point is to get started. We need to change the way we're doing things so that we can expect different or better results. This typically means changing the culture and the organization to better address the issues that affect reliability. This webinar presentation takes a detailed look at what was done, how it was done, who delivered it, and what results were achieved. At the end of this webinar, we will review the who, what, when, where, and how of an instrument reliability program so that you can start on your asset management program as a result of this webinar. Our speakers today are Shadrach Stevens and Chris Garcia of the Dow Chemical Company. I ask that each will introduce themselves as well as the other team contributors to this successful program that they're about to tell you about. So our first speaker today is Shadrach Stevens. Welcome, Shadrach.
Thanks, Chuck. First off, Chris and I would like to say we really appreciate the opportunity to present this case study to the many professionals on the call. Our goal this afternoon is to showcase the infrastructure and tools that we use to deliver that 85% of savings Chuck mentioned. As you know, reliability is the gift that keeps on giving. And so with that being said, as to technical professionals, we have an obligation to really inspire others so that they can also positively influence behaviors within their own work groups. And so throughout my career, I've had the opportunity to work with several Fortune 500 companies, and within our own reliability program, I've pulled together many of the improvement models and tools that we've used to create a comprehensive strategy. Okay, so first off, I'm Shadrach Stevens. I am an instrument and electrical maintenance group leader for Dow Chemical. I have a bachelor's in electrical engineering and about 11 years experience across multiple industries. And specifically, I have 5 years experience within Dow. And joining me here in a few moments will be Mr. Christopher Garcia. Chris is an I&E technology leader for the Houston area operations. Chris has his associates in instrumentation, and he's pursuing a BS in electrical power engineering technology. Together with Dow and Roman Haas, he has 20 years of experience within the discipline. And also listed below are some of our major team contributors. These individuals don't necessarily get a chance to travel with us as we go from conference to conference, presenting some of the results and successes of our program. But as Chuck mentioned, it is a team sport, and we want to try to make sure we always give recognition to the other folks behind the scenes, pretty much at the ground level, helping us to unveil this reliability strategy. So our agenda is going to be as follows today. I'll start off with an explanation of understanding the needs and the challenges from end user standpoint. And since we work at a chemical facility, our customers within the maintenance organization is going to be our production partners. Those are the folks that are in operations that helps us solve some of these technology problems. Next, we'll have a brief discussion on our instrument reliability model. And our model is basically broken up into two sections. We have our short-term solutions and long-term strategies. Next, I'll talk a little bit about the infrastructure that we created to be able to provide this foundation of reliability improvements. And then finally, Chris is going to help me kind of go over some of the ways we sustain the gains, what our control plan looks like, so that if people within our organization move around, that we're still able to deliver value. And then we also talk about a few of the success stories or a couple of examples of the case studies that we had when we rolled out our program. So one of the first things I've learned as I started my career in engineering is that before you begin any type of improvement strategy, it's always important that you document what the baseline is. And that's mainly to track whether or not your improvements are actually delivering value. And it's even better if you can represent your baseline pictorially. So this was a representation of how we got started back in 2011, and what I call our case for change. This is what our opportunity was regarding instrument reliability. If you look at the Deer Park facility, we have 67 process units, and within those 67 units, there were 5 units, specifically 5 reactors, that were accounting for about 50%, almost 50% of the total instrument and control valve equipment failures. And so that means you had millions of dollars in production losses related to only 5 units, 8% of the entire population. And I bring this up because one of the things you want to do as you roll out your own strategies is quickly identify the biggest bang for the buck, right? You're going to invest resources, time, and energy, money into rolling out a strategy. You always want to have quick results. And so the best way to get that is if you identify what the biggest bang for the buck is. And in our case, which made it actually a little bit easier, is that those 5 reactors all had similar process technology. So that means the equipment was relatively the same from reactor to reactor. If we were working on a strategy or an improvement on one train, we could easily leverage that over to the other 4 trains. And so that basically helped us gain some momentum with our leadership as we began to roll out this program. But the main thing is I want to get across, always document what the baseline looks like so that you can show to your leadership, hey, we're moving or we're tracking towards delivering value. And so just to kind of fast forward a couple of years, if you look at 2011, we started at around 50% of the site's downtime. After 1 year of implementation, we dropped down to 16%, so we made a significant step change in the reliability strategies that we implemented. And then the end of last year, we got down to single digits in downtime across the site. And so, as I mentioned, that it's one of the key things is to get that baseline so that as you show progression year over year, you can continue to gain more momentum with your leadership partners. And this slide just recognizes that we are, or validates that we're on the right track with some of our value creation. Okay, just like I talked about, you want to show the baseline before you begin any improvement strategy. One of the things that we did to get us kick-started off was we held what you call a Kaizen event. Before coming to Deer Park, I've had some experience working with continuous improvement models, and so what Kaizen is the Japanese word for continuous improvement. And one of the things that I learned throughout that developmental stage of my career was that it's always key to pull in resources outside of your own natural work group so that you can get a different pair of eyes to see where the challenges are. And so one of the things we did first off was we held this Kaizen event, and we had a couple of brainstorming sessions with the leaders. We asked them a lot of questions about some of the challenges within the facility, but this one specifically kind of stood out, and that was, what are your needs? They came back and said we need reliability strategies and also immediate improvements. And so as an engineer, what that translated to me was we need to stop the bleeding, but then also move to a more reliable-centered culture, right? We need to have more strategic thinking on the way we solve some of these problems. And they gave us a ton of feedback, and you can kind of see some of the examples listed there on the screen. But there was so much information that we couldn't obviously work on it all within the first year, so we began to really segment common brainstorm ideas. And we had 4 main categories. We had a lot of old or end-of-life instruments. We had lack of PPM strategies, or not strategies that were not robust enough. There were a lot of repeat failures. And then also had some, what we call here in Dow, is operating discipline challenges within the people or the process. Those are the management systems we have in play to keep things running consistently. And so that first off, that brainstorming session kind of helped us gather all of these ideas and funnel them to try to start creating an overall model. And on the screen now, it shows from those sessions, we're able to get a good sense of where the leadership thought our problems were, which is also very key, because when you begin an improvement strategy, if your leadership has bought into it from the early stages, you can continue to push through with that momentum. It's extremely difficult that after you start a new program, a new project, and things maybe not working correctly, and trying to get the leadership engaged after it's been started. It's very difficult. That's some of the things Chris and I have learned is if we want to make sure that this program is successful, let's get them engaged early on. So after that brainstorming session, we came back and said we're going to create a model, or what is going to be our approach to solving some of those challenges. And it's broken up in the 2 tiers. The first section is short-term, and within the short-term solution space, we created 2 more buckets, which we call reactive and proactive. I won't go through all of these individual services, but I'll talk about a few of them today. So, for example, trip investigations. Every time we had an unplanned event on one of those reactors, we actually conducted formal and informal root cause investigations. And so within the first year, we had about 52 trips in that first year. And what we're trying to understand is what were the root causes to those unplanned events? What are the short-term things that we're going to do? What are the things we can do day-to-day that's going to address that issue? And then long-term, what is the strategy that's going to sustain whatever improvements that we made? So we taught all of our technical staff, from myself, engineer, to technologist to technician, on really how to thoughtfully think through problem solving, which is something that is kind of unique, because if you go across the industry, most of the time only reliability engineers and maintenance engineers conduct what we call RCIs. But we really got the training at the ground level to the folks that are actually solving these problems. On the proactive side, one of the buckets that we began to deliver in services was instrument assessments. One thing that we found out during these brainstorming sessions, that we had a lot of old and end-of-life equipment. And so we got with leadership, and they were supportive in us doing what we call instrument audits. So we'd go out in the plant and spend extended amount of time going from point to point and assessing each device. And the reason why we call this more of a proactive strategy is because we know we have obsolete equipment out there, and so all we're doing is basically waiting for the device to fail, and so we can be reactive to go and change it or upgrade it. And so we're saying we're better than that. We can step the game up a little bit and be more proactive. And so we're going to talk about, Chris is going to mention what we did regarding those assessments. Moving to the long-term strategy space, we had 2 buckets, what we call RCC, which is Reliable Centered Culture, and Instrument Engineering Projects. And so all of that work that we did on the short term, that data or that information was fed into the long-term strategies. So, for example, equipment maintenance strategies. We in our industry, or at least in the plants that I've worked in, there has not really been a burning desire to create EMSs for instruments and control valves. And so as we started to dig deeper into our unplanned events, we found out that the technology that caused us the most reactor trips were control valves, and mainly because those technologies have the most moving parts in them. They experience more wear and tear versus sensors and transmitters. And so we put some things together, and we'll talk a little bit about that in the up-and-coming slides. And then finally, I'll talk about the technology upgrades. So as a result of doing these investigations, doing these assessments, also putting together strategies, we selected a handful of equipment that could actually go to what we call the MET, which is most effective technology, something that we've defined as being the best in class for that particular application. And we started front-end loading capital project work so that we could make these necessary upgrades. So, I'm not going to go through all of the pieces today, but I wanted to give you guys a sense of the overall model that we chose to use in our approach. And some of the key learnings that we had when we developed this was we used the data to get others excited. As I mentioned, we brought in our leadership early on, and we started showing them pictures, started showing them these RCIs, started showing them data that shows we truly have a lot of issues here with our instruments. And you always, working with leadership, you always hear, instruments are acting poorly, we have poor measurements, but no one ever actually sits down and takes the opportunity to share with the leadership what that looks like. So we'll talk a little bit about how we use the data. I also use the technical experts. As a reliability engineer, I'm only one person, and there's plenty of resources out there within our technicians, technologists, even our suppliers, pulling in resources from outside of the plant to help you solve some of these problems. Next is set expectations and train. I can't stress this enough, how important it is to really, before you roll out your own strategies, is to make sure you have alignment with the individuals that are going to be responsible for delivering the value, and you got to train them. I mentioned one case where we trained our technician how to do an investigation, or we also trained them how to use the data historian so that they can track their own instruments. And finally, I want to say everyone is a 10 at something. I heard that statement a long time ago, and I definitely believe in it because every one of the team members has a strength. And your objective as a leader is to try to find what their strengths are and then align them to whatever strategies works out best for what tool sets that they have to deliver. Okay, so let's talk a little bit about the infrastructure and what we call our foundation before we actually put the boots on the ground and start solving problems. This was a snapshot of our original infrastructure. At the very top layer, you have what you call an instrument reliability engineer and also instrument discipline activity specialist. These are the two folks that kind of give the overall vision for the facility. And the second tier is what we call our instrument focal points. These are the technologists within each of the plant areas that help execute some of those strategies or that vision. And at the lowest layer, we have our technician. And our original structure included dial technician and also contractors. And so we had a central pool of these technicians and various challenges with that. All work kind of filtered through this central pool of folks. And we started noticing we're having a lot of turnover, mainly because of stress-related from individuals working from plant to plant to plant. They feel like they had no ownership, really, because they could be working in any area on any given day. The technicians were kind of in a reactive mode. We did not have any strategies in place to focus on reliability. And so when something breaks, we just fix it, right? We just change it out or get something off the shelf in the warehouse and replace it without truly understanding the root causes. And I want to talk a little bit about the workmanship. You could be a technician working in Area 1 today and then working in Area 2 or Area 3 tomorrow. If you had a list of bad habits or bad behaviors, you were carrying those behaviors across the entire facility. And so we kind of said we got some major challenges with having this central pool within our structure. So we went to the leadership team and we proposed a new structure. Now, I know it looks like there's more people added on the slide, but we actually didn't add a ton of people. What we did is realign some of the folks we had within our areas. And so at the top layer, we still had the engineer and the DAS. What we did do is infuse the group with a team of special project technicians, and those folks were only to work on reliability projects. They were not bogged down with the day-to-day efforts within the plant. The next tier still kept it the same with the focal points, but what we did do is take some of the dial technician and promote them up into what we call a reliability technician. And so those roles were concentrated half of their time in the plant solving problems and the other half of the time working on reliability strategies. So the instrument focal points had a resource of someone that could spend more time in the plant helping them deliver their strategies. And then on the bottom layer, we actually segmented technician to be responsible for certain areas. And so with that, we're able to control a little bit better the workmanship. Also, we can train folks depending upon the technology that exists within those facilities. And it helped us to really set expectations. We said, okay, we've got a handful of techs that are going to work in Area 1. If something fails, you are responsible for creating the solution for that. Okay. And so we had the infrastructure. We worked with leadership to really define or get approvals to adjust the people within the infrastructure. And with that, at the same time, Chris and I were working in tandem, creating an overall strategy document. And it was about like a 50-page document that says exactly what we would do at each step of the process. This was basically our approval document for the leadership so that they can say, okay, we agree that this will be the strategy moving forward for instrument reliability. The key, items within that document was we created a work process for every single service. So, for example, how to do an investigation. We got a who, what, when, where, and how, each of those sequential steps on how to progress through solving that problem. And so this is, some of the things that we use to train our technician and also to keep consistency within all of the plant areas. Thirdly, we created procedures. So an example is for our instrument assessments. You got different skill sets of technicians throughout the plant, but in order to drive the consistency on how we assess an installation, we had a sequential procedure that said, okay, you're going to do a visual assessment, you're going to look for these things. If it's in this condition, you're going to mark it up with a score. And so at the end of the project, we're able to score all of our installations. And then the fourth item was investigation reports. These were the documents that we forward along to the leadership every time we solved a problem. And what this did for us is it continued the momentum and the buy-in because the leadership saw that we were actively engaged in finding these root causes. We're documenting what we found, even created action registers to be able to solve some of these problems. And at first, the engineers were doing this, but then eventually the technician learned how to create their own reports. And so they started sending information up to the leadership chain. And so those 4 steps kind of all fed into one bucket, which is execution. We could do all of these things perfectly, but without actually going in there and solving these problems, then we would have gained nothing. So we put a lot of PMs in place. We did some front-end loading for projects. We did a lot of MOCs to change some of the culture challenges that we have within the organization. So the main intent of this slide is to share, as you start developing your own strategies, make sure you do a great job in documenting your approach. Because if something like, for example, Chris and I, within the last year or so, Chris and I have both had promotions. And so we're not actually working in this facility anymore. And we're going to show you guys in a little bit some of the data. The guys that are still maintaining this program are actually doing much better now than when we were here. Okay? And that's because we took the time to create the program and document it so that now we're in different positions in our career. The folks are still driving the process, using the procedures, and doing the reporting. Okay, so the next few slides are going to be more about the case studies or the examples that we use to solve some of the problems. As I mentioned earlier, we had kind of an operating discipline challenge with control valves, and as we Pareto the data from year to year, we found out that control valves was one of our biggest bad actors in terms of reactor trips. And so if you look at the data on the slide, for a 3-year period, we saw an uptick in reactor trips. And we started to ask ourselves, what could we do to really swing the pendulum the other way? Okay, so we said, obviously, with control valves, the best thing to do is to do some type of maintenance and repair. Okay, so in the first year, we actually started to do that. And we have 5 main categories that we focused on for that first year. We did a criticality ranking on all of our control valve installations. We worked with the production engineers to define which valves are actually critical or that could cause a reactor to trip offline. Secondly, we created PPM strategies. And so in years past, we had some preventative maintenance plans in play. What we did differently here was we put it in our CMMS so that it could automatically generate work orders so that we can perform these PMs. Next, we created a spare part strategy for those critical valves because our turnaround windows are from 3 to 6 years. And so what if we have an incident in between time? Do we have spare parts or spare control valves so that we could get the plant started back up? We also created procedures. Most of our, well, I can say not most, but 100% of our valve work is done at a third-party facility. So it's done off-site. And so how could we drive consistency with our repair vendors? And we decided we'd create a procedure. We will give the vendors an expectation of all of the control valve repairs so that we could get work done and executed within the same consistency. And finally, we validated design conditions. So we looked at individual installations and saw that, hey, per the process criteria, this valve is not designed properly. Okay, so we did that in the first year. We started to see a downward trend in our valve trips. The next year, we actually started to see a huge step change in the valve trips. And one of the things we did now was we actually created this document, this equipment maintenance strategy, and we started to actually implement it across all of the trains. So the first year, we was kind of manually pulling valves, getting them repaired, but we said this is no way to sustain this program, so we're going to document our strategy, put the PPMs in play, put the spare parts, get them ordered, put them in a warehouse. And then we also took into account, we had an asset management software where we could start monitoring our digital positioners on control valves. And that really changed the game for us because now with using that hard data, that hard information, we could predict when a valve is going to fail by using the performance curves on the equipment to be able to tell whether or not a valve had a problem, or to set up alerts and alarms, which are a little bit different from what you see in a DCS. And so that made our biggest step change as we started using this condition-based monitoring or maintenance strategy. So kind of talked about some of the success stories, and on the flip side, got to talk about some of the bad stuff as well. As we begin to roll out the strategy, 4 out of the 5 trains, we were able to implement it. One train was still lagging behind because of business conditions. They actually extended the turnaround until the next year. Okay, that was the one train for 2013 that had the most trips. And we actually went back to the leadership and said, look, we have a good program, we're rolling out, we're seeing some success, but this one train is the bad actor now. And we have the data now to show why it's impacting our strategy. So within that next year, we were able to get that EMS implemented for that one particular train. And if you look at this year so far, we've only had one reactor trip. Going back in time and looking at our 3-year trend, as things were going upwards, now we've swung that the opposite direction. Okay, so a couple examples of using diagnostics with control valves. This was an installation that we had on our governor control valve. And so the governor valve is pretty critical for our reactor train because we're using it to control the airflow and the steam flow going into the reactor. And without getting any DCS alarms, we noticed that with our asset management tool, we got travel deviation alarms. And you can kind of see in the graphic there where we set up a triggered profile that would actually give us an alert every time we had excessive travel deviation. Okay, and so with this particular valve, we went out in the plant and said, oh yeah, we got to perform some maintenance on a positioner with this valve. But our operations partners did not want to give the valve to us to work on it because in order to work on that valve, you got to take it out of service, which in turn shuts down the process. And so we continued to push the topic, and they said, you know what? We talked to our commercial folks and the business team, and we actually have enough inventory saved up to where we can reduce rates. Okay, we'll keep the valve running at a reduced rate, and then we'll take a planned outage and make the necessary repairs. So a few weeks later, the plant came down for a planned outage. and we were able to get in there and actually found out that it was a loose bracket and the positioner began to fail. So we made the changes, and now the valve is working great. But we did this all without taking an unplanned event. And then the last piece I want to talk about is we were using control valve, EMS strategies, and condition-based monitoring to stop trips, to stop unplanned events. We also use the information to help us reduce maintenance costs. And so we had a situation last year where a turnaround we were getting ready for execution of the turnaround, and the business came back and said, we really want to reduce some of the job scopes for budget constraints. And so, as we always do, we perform performance curves on each one of our critical valves. And so we went through that exercise and actually found out almost about 36% of the valves could be removed from the scope of the turnaround because they had no problems with them. Okay, and the graphic here shows one example. This valve was on the list to be overhauled, and we performed our scans and found out it was like a couple $100 travel sensor. So instead of looking at spending about $10,000 or so for this particular valve, we spent a couple $100 and was able to keep it in line without taking it out for service. And so we did that across our 42 valves, and we were able to get, almost $127,000 in cost avoidance. Okay, so next up is Chris, and Chris is going to talk to a couple of other case studies.
Okay, thank you, Shadrick. Well, as Shadrick mentioned, the leadership in our business, customers came to us and asked for help, and I pretty much said, hey, where can we start? How can we stop the bleeding? So some of the things we did was we started with assessments and engaged our reliability focus group, the special projects group, in identifying the deficiencies. So to help with those assessments, we created visual inspection checklists for the different technologies, as Shadrick mentioned earlier. That way you can keep consistency in data collection and assessing. So once collected, the data was downloaded into a database so we can help manage the deficiency categories and repair priorities. So using that database, you can then determine what can be corrected or fixed with or without a work order. So of the 10,000 assessments, we did find 2,400 deficiencies, and then ultimately we did find 400 deficiencies that required a work order to fix it. So I just want to briefly focus on the pictures a little bit, starting with the top left-hand one. These are some of the deficiencies that we did find, so probably pretty common. A lot of y'all have probably seen the same type of issues, but the top left-hand corner, that's a vent plug missing on top of a control valve actuator, and you can see there's water dripping directly over the actuator, so that could greatly reduce the end of life or the instrument's functionality. The next one on the top right is a limit switch pack housing on a RCV. Still has a shipping plug in there. That should have a regular plug. As you can see, moisture did make its way into the limit switch pack housing by looking at the beacon. It does have moisture accumulated. The next one, moving clockwise, you have a temperature transmitter. We found it full of water. You can see the rust and debris in there. All this could have been eliminated by installing a low point drain. And then the last picture, you see an RCV with a solenoid valve on it. You think, okay, what's wrong with that installation? Well, if you look on the far right of the block, you have an exhaust port. It's a screen. It's facing upwards. When it rains, that screen can be absorbed. Absorb water, and water makes its way into the internals of the solenoid and, again, can affect its functionality. Okay. Another way to monitor the health of your instruments is what we did. We actually used a tool or software that we already had, and we were actually using our data historian to collect data. So with the assistance from the operations group, process automation group, and our tech center associates, we created an online monitoring system for the 5 units and using our data historian software. So what we did, we just created a simple dashboard. That way you can see the status of your redundant instruments, and it's real easy to see. So you have green, yellow, red. Green is good. Yellow is hey, there's something wrong, but it doesn't require immediate attention. And red is, hey, there's something wrong between the redundant instruments. Let's go and investigate. And the ops and the process automation group, they helped us identify which critical redundant instruments to put on this software and help set the alarm limits. And I tell you what, this was a key contributor in helping us with our investigation processes and helping us solve problems and leverage to the other units if needed. Okay, next slide. There were 2 technologies on our top opportunity list that had a huge impact on our business and big repeat failures. So over a 2-year period, these technologies accounted for multi-million dollars of process losses. So our group got together and we said, hey, let's find a new technology, or find a technology that's new or make improvements to our existing technology. That way we can improve our reliability and down the road doesn't require much maintenance intervention. So after thorough research and data collection, we did identify that, I guess, first of all, the 2 most top opportunities were temperatures in incinerators and levels in boilers. And again, after our thorough research and data collection, we did identify for the boilers that a guided wave radar would be the best selection. And for the incinerator temperatures, we would improve the metallurgy and the sheath thickness. So with the radars, our reason for going with the guided wave on the boilers was you did not have to worry about a whole lot of ancillary equipment affecting the performance of your level measurement. So sometimes you can have issues like heat tracing or tubing leaks or loss of fill and greatly affect your measurements. And then for the temperatures, we just upgraded. We kept the same technology, but just upgraded the metallurgy and the sheath thickness. So it took a little bit of time, and we spent some time on this project, but we upgraded from stainless to Inconel, and then from Inconel to Incoloy, and we found something that was good and got our metallurgist group involved to help us solve this problem and get down to the root cause, and instead of just hey, slap another one in and go with it. So the Incoloy was the best metallurgy to help with our process.
Okay.
I'm going to turn it back to Shadrick.
All right, so at least the audience has got a chance to see a few of the case studies that we had when we rolled out our reliability program. And so I shared earlier that we're kind of going to progress through the years of implementation. So if you look at our baseline, before we actually rolled out some of these strategies, we're averaging around 50 trips per year. Within the first year of implementation, we got down to, I think it was 26 trips in that first year. And every year since, we continue to drive the improvements across all of those 5 trains. And so year to date, we're at 94% reduction. We only have, I think, 3 trips this year, which is a tremendous overtaking over the course of what our baseline was looking like. And so with that being said, the way we rolled out the program, got leadership engaged, et cetera, we're able to continue to drive the momentum with delivering this value, or even asking for more resources, more capital money to continue to drive these improvements. So overall, a major success across the board. And as I mentioned earlier, Chris and I aren't even in the plant anymore, and the technicians are still driving towards understanding the root causes of the problems, coming up with short-term solutions, and then getting to a position where we can implement long-term strategies. And to kind of wrap up here our discussion this afternoon, as a result of those strategies and our implementation team, our group of folks, or technician and engineers, technologists, was selected to win the Hart Plant of the Year earlier this year, and mainly because we were using a lot of the diagnostics information from smart devices to be able to be more proactive, save more maintenance costs on those particular 5 reactors. So our team was actually presented this award earlier this year, and which was also another great testament to not just Chris and I, but it was an entire group of folks that worked on this particular project. So with that being said, I'm going to turn it back over to Chuck.
Thank you, Shadrach. How exciting! This is it was an excellent presentation, and hope everyone, all the attendees, have found value here. As a means of doing a review, I really need to point to the culture and organization changes that Shadrach talked about, because it does involve doing things differently. It's so easy with everyone being so busy and so many things to do to just keep doing things the same way, or blaming this or blaming that. The key is to step back, think about things differently, get organized, and let's try to change the culture and start using all the resources that we have available at our disposal. So a quick review. I promised during the introduction that we'll look at the who, what, when, where, and how. So here's a summary as to how we answer those questions. And the who is build a team. The team could be one person to start with. It could be a small group of you trying to make it a decision as to how to go about utilizing the knowledge and the resources available at the plant. The what, identify real problems. Low-hanging fruit, start small. Identify a real issue that you can work on and solve that one first, and then hopefully things will open up and get more people involved. Where, this team, create the team. Select a known problem in an area of the plant where you think you can get team support. Team support probably includes management. It may, at different levels. You may have to start low and work your way up, but the more people you can get involved and the more consensus that you could build, the better off you're going to be. When? Well, that's the issue. Let's start today. I don't believe any of us can wait until tomorrow or next year in order to get this, to get the culture in the organization and to get the improved reliability at your facility. And how do you go about doing it? Let's ask questions. Bring the group together, as Shadrach suggested, and brainstorm it. Flow chart it. Use whatever technique is standard or is typical at your facility. And use the assets and resources that you have, even for in areas that you're not familiar with. Bring in people from the different foundations about the communication protocols, or bring in people from the FTT group to talk about the different resources available there, and of course your own automation vendors and device suppliers. Don't hesitate to call them in and ask them about the information that's included in their intelligent device. So, culture and organization change really doesn't have to do with the age of your plant, has nothing to do with the big control system, old control system, anything like that. Has nothing to do with the scale of your plant, how big or small it is. Cost, it might involve a little bit of cost, but once you start showing some of these successes, you may be able to get your management's attention and hopefully start improving the reliability of your operation. We certainly want to thank Shadrach and Chris for the presentation today, for their time. I think it was an excellent presentation and really gives us an insight as to how something was really done, and then take a look at the dramatic results that happen in just a handful of years. Okay? So with that, we'll move into the question and answers, and I'll turn it back to Stacy.
Thank you. Okay, we'd now like to move into our Q&A session of this webinar. We've already received some good questions, and I encourage you all to join the discussion and submit your questions at any time using the Q&A box on the right-hand side of your screen. So we're just going to jump right in. We have a question, guys, that asks, in reference to the operating discipline control plan, the question is, can you share the example of these 5 documents? I understand that it would be difficult to share DAO documents, but if you can share sort of the the example for the strategy and work processes?
Sure. Yeah, definitely. I think you hinted on that within the flexibility of presenting this information. We also have some commitments of not being able to share content directly with folks external to Dow. But what I'll say is maybe we get the individual's information and we have an offline discussion about more of the higher level templates that were used. But yeah, we can't really share specifics about it. But one thing, this is what I will say. I think as Chris and I got started on the project, we like to coin the term package our passion. And what we were doing was, Chris is extremely passionate about instrumentation. I'm passionate about reliability engineering, and we partnered on creating what the customer needs were. Okay, so I think, there's a template that you can follow through and get through the execution, but I think you really got to take what you're good at doing and then spending time to get the voice of the customer, because really they're going to give you the hierarchical flow chart, if you will, of where to solve the problems. In Chris and I's case, top 10 bad actors, instrument assessments was high on our list because the leadership said that those were the problems, and we confirmed it with the data. Yes, those were the problems. And so, as in any problem-solving methodology, the first thing you want to do is to get some feedback. The next thing you want to do is validate that the feedback is accurate. Okay, and in the process of doing that, you want to try to attach a financial number to that opportunity, because that's really what gets folks excited. If you can say, hey, one unplanned event cost me this much money, then of course if you have several of those, then you can get some more momentum built to invest in money to solving that problem. And so I know I'm kind of talking high level here because I can't really share some of the exact details, but that model that you saw with short-term and long-term, that's actually not a new strategy in terms of instrument technologies. We've been doing that for the last 20, 30 years. Ever since automation became a big push across our industry, folks have been doing equipment maintenance strategies. Folks have been doing visual assessments. They also been using diagnostics. So those items aren't new to the industry, but what is different is how you go execute it, and do you have the right infrastructure to go and deliver that. When talking to some of the folks in the conferences, we found out is they don't have enough people to support their ideas. And so that's why I think, one of the first things you want to do is get the leadership engaged, let them tell you where the problems are so that they feel that they have buy-in in the beginning, and then attach a financial number to that. So that's my advice so far.
Okay, great. And the attendee who asked this question, the presenter's email addresses are on your screen right now, and I will also pass along your email address to them so you guys can continue this conversation one-on-one. Moving along to our next question, though. Looking at Dow Chemicals, it looks like a fantastic success story. How does a solid instrument reliability strategy help in a plant that doesn't have a lot of trips or control valve failures?
Okay, I'm going to try and answer this one. I'm assuming maybe they may have some reliability issues, but it's just not greatly affecting, but still they want to focus on a reliability strategy. So what I would recommend or suggest, just to see, maybe take a sample of one of your units and go out there and assess and see. Of course, use some of the the data do some data mining from your wherever computer maintenance management system or other means that y'all are using to help and guide and set the pace on where to go.
Okay. How did you get management buy-in for creating the new infrastructure?
I think I'll take this one. To parallel from what Chris just said and his question and this new question, It's really about show me the money, right? If you look at how those reactor trips were affecting our business, our commercial side, we're losing a lot of money in terms of production and selling to our customers. And so reliability is definitely a bottom line impact in terms of how successful your business can be. Not necessarily how well do you manufacture a product, but can you actually produce a reliable product and also deliver it reliably to the customer. And so for us, it was easy because we had the financial backing. But I will say it took a lot of research and work with the financial folks to really quantify the cost of what a reactor trip would be. But that's a discussion you take outside of your reliability group, and you have that with the leadership. But I think if you can pinpoint what costs you the most, in reliability principles, they say the cost of unreliability. It does not have to be necessarily a trip, but whatever costs you in terms of running your operations, that's where you focus at. And that's really how we got our management buy-in, because it was hitting our pocketbooks. It was hitting a direct impact to our bottom line. And so throughout that first couple of years, our production facility was actually sold out. So when we can't make a product, we're losing an opportunity to make money for the company. So that was our burning platform.
Okay. Next one. We have a similar program at my facility, but the operators that review the reliability of the equipment are viewed as not doing work or helping. The operators are said to be just adding to the long list of work orders that already are not being completed. How would you get the view of these changed or get the work done?
I'm glad that was brought up because we had a similar instance when we first got this program started, and we can laugh about it now looking back. But when we finished the assessments, you saw in the slides we had 400 work orders. Well, we created all 400 work orders at one time, and we flogged the system. And you want to talk about a backup? It's like we backed up the sewer, and we kind of got scolded a little bit. So what we did was we took a time out, went back to the drawing board, and reviewed all the work orders up against the database that we created, and used the database to set the priorities on the repairs. Right now, of course, everybody has a budget. You can't fix everything in one day or one calendar year, but if you can prioritize that, and Shadrick mentioned, maybe it kind of go both ways. You can hit the low-hanging fruit that doesn't cost a whole lot to repair, but at the same time, look through that database or your assessments and see which one has the biggest impact in saving money, like in producing better yields or reduction in loss of pounds or loss of production. That's what I would recommend. And I guess the other one I'm gonna move a little fast on you, but IDAS stands for Instrument Discipline Activity Specialist. That's basically like an instrument specialist or instrument technologist. The main resource for the instrument technicians and maintenance people.
Yeah, and I want to follow up on the leadership aspects of that first question. One thing that I would recommend, or that you can consider doing in terms of working with your operations partners, is, remember I talked about voice of the customer, understanding the needs, and so I almost guarantee you every one of those operators has a need right now. Okay, and you might not understand it today, but I would really invest a lot of time and say, hey, out of all of these devices in the plant, which one is causing you the biggest headache? Okay, and really you got to start developing a relationship with operations, because we're not working against each other. We are a team, and I think if you can help meet a need that they have been fighting with for many years, that helps you get a relationship started and developed, and so that maybe the next time they're a little bit more open to receiving the strategy you want to roll out.
Okay, great. How are you able to sell the idea of installing condition-based monitoring equipment, such as equipment or asset management diagnostic tools?
All right. I'm going to take a stab at answering that. and I might be right or wrong, but we'll go for it. When I came into Deer Park, that asset management tool already existed, and actually, it had been installed in the plant for at least about 5 or 6 years. The culture prior to me getting here was still a very proactive culture. What happened was we made an investment years ago because we had a lot of control valve trips. Okay, we could justify the cost of that AMS system based upon we would deliver a return in reliability value. Okay, so the tool kind of like paid for itself. The challenges that we had were that once the tool was implemented, things were working well, we made some changes in our infrastructure. And so we no longer had the support to keep driving the asset monitoring tool. And so as the folks left the organization, you could see the trips start tracking back upward. And that was really, one of the things that helped us start early on was every single thing we would do, we documented the process, the approach, because in case somebody or a couple people leave the organization, we had a plan for the next person to come in and be able to execute. But in terms of getting the buy-in for the tool, in our case, we just had a lot of downtime. And the downtime was high enough to whereas we could afford to purchase the asset management system and pay for it with reducing that downtime.
Okay. On a very practical basis, knowing that we do very little with our smart devices today, what are the 3 or 4 key steps or actions we should take to get such a program started?
Well, I think one of the first things you have to definitely do is get the folks at the ground level engaged. Because no matter what strategy you put out there using smart devices, if the technician don't know how to use the tools or don't know how to really get to the digital data, it won't be successful. And so I think you really spend time. What we did was basically we had created an environment for proactive culture. And so when we cleaned up our AMS and got it back working again, the technician it's like an exciting new venture. It's like, we got this new tool. Hey, that's going to help me solve problems in my facility. So the technician had more ownership, and the asset management was just a tool. It wasn't the problem solving. It was a device that gave us more information to help solve more problems. But I think you really spend more time in the development of your technician and the training and say, hey, this is an additional tool in your pouch that you can use to go and identify these root causes and solve problems.
Okay. At first, were the ones supporting you with your reliability efforts a little leery, thinking that this was just another flavor of the month?
Yeah, they did. I'm sure everybody at some point has experienced, when something new is rolled out, they're like, okay, how long is this going to last? Well, I think Shadrick mentioned it was key that we were able to provide so much value and then also get buy-in and help build our infrastructure. And I think that's the way that one of the ways that we're helping or being able to sustain what we're doing.
I'll chime in with Chris on that. One of the creative things, and I say creative, it's not really creative, we should be doing this anyway, is we started engaging our suppliers. Okay, these are the folks that design and manufacture these products that we use in our facilities. And when we brought these individuals in to help us solve problems, they actually did the job of communicating the types of failures we were having back to the technician and back to the leadership, so that it's almost like they're a better representative for the information to come from someone who made that equipment versus someone who performs maintenance on it. And so we really took advantage of the relationships we had with our suppliers. And it's very difficult, if you're a leader and a supplier tells you, hey, that transmitter failed because it was overpressured by the process. And here's some information to show, maybe, you got a telltale that tells you that information, and it's hard to debate that leadership person with that information. So I would encourage everybody to use their suppliers to help with solving problems.
Kate, can you elaborate a little bit more on getting a baseline from the plant and what should be the first steps in that direction?
Okay. The baseline, and I mean, it's pretty simple. Just document what the historical events are. And events does not necessarily have to mean, like in our case, reactor trips. It could be EH&S events. It can be Title V deviation. So in our industry, we have operating permits, and every time we extend above the parameters of those permits, we get Title V deviation. So I think what you got to do is really spend time with your leaders to understand what is the most important item to track in the environment that your business is in. It does not always have to be reliability. It can be EH&S. It can be maintenance costs. Some plants, they're built very robust. They have triple redundancy. They have a lot of what I call bypass around devices, so they don't shut down a lot. But maybe their maintenance cost is real high. So as a reliability professional, our jobs are there to help reduce costs any way that we can, and also help impact the safety and the environment of our facility. So I would just say use whatever information you got available. If it's not great data, then don't stress about it. Start pulling in new data, clean data, so that you can start making database decisions.
What advice can you give as to how to justify the time and resources this may take to implement, knowing that we have so many other so-called critical initiatives going on at the plant?
I think, and I've seen this across our industry for the last few years, everybody's talking about short-term and long-term. I think if you have an approach that is only short-term, you're going to lose the benefit of being a little bit more proactive. And so whatever strategy, you might not have all of the things that we did, but I think you should have a strategy that is at least one component is more proactive. And I think you really got to show the numbers. In our case, visual assessments did it for us. I remember our first meeting we had with the leaders before we did our brainstorm session. We just did a PowerPoint with nothing but pictures, and we flashed through each of the pictures, and we explained, because in our discipline is more mechanical folks than instrumentation and reliability. So a lot of times the guys don't understand how the technology works. So with us showing the pictures and explaining why does a vent cap missing on a control valve, why is that important? Okay, let me show you the water built up inside of the actuator. So I think if you take the time to show and train and teach them what the deficiencies are, because a picture's worth 1,000 words, and it's difficult to explain that if they cannot relate to your technology.
Okay. We have smart instruments but no smart valves. Would this program also apply to measurement instruments, and what kind of results might we expect?
I think we in our program, in terms of smart diagnostics, we did not use it for instruments, but that's something that the guys are looking at now. One thing I would consider is every production facility has raw materials that they use, and pretty much is one of the largest manufacturing costs that you have for your facility. And so, for example, flow meters are critical to your operations because they basically measure how much of raw materials you're using. And so you might, look at installing the smart diagnostics or smart information from flow meters so that you can tell the accuracy of a meter without having to pull it from out of the line.
You present a very good message as to what results can be achieved when a team works together. But I feel I need to start by myself to show management what kind of information is available and what results we could expect if we really took action on a potential problem. Do you think my device suppliers would be willing to train me and help show what we could do?
And we got a lot of support from our suppliers, the vendors and the manufacturers in helping us with our asset management or our condition-based monitoring tools, along with other smart instruments. So that's never ending. You'll find that a lot of your vendors, you'll create good relationships, and they're wanting to come out there and help train your guys, because in the end, ultimately, using their products or their diagnostics will make it better for everyone.
Okay, these have been some great questions. I want to thank you all for participating. As always, we'd like to thank our sponsors for helping to make today's webinar possible. If you missed any portion of this webinar, or if you would like to watch the recorded version, we will be emailing all registrants a link to the recording along with additional links for supporting information. Be on the lookout for an email from me in the next couple of days. Additionally, once you close out of this webinar, you'll be prompted to take a survey to provide us feedback. We're always looking for ways to improve our webinars, so please take 2 minutes to fill out the survey. Your presenters today, Christopher Garcia and Shadrach Stevens, will both be in attendance at ISA's Process Control and Safety Symposium. Be sure to stop by and talk with them. The event will be held October 6th through 9th in Houston, Texas, and for more information and to register, visit isa.org/PCS. This concludes the key work, process, and organizational changes for successful asset management webinar. Thank you for attending. We hope you acquired useful information and hope to see you again in one of our future webinars. Have a good day and an even better week.